All right, so we've been working with sequences. We've been talking arithmetic, geometric sequences. Both of these types of formulas will apply still to both arithmetic and geometric, but I want you to become familiar with this vocabulary here. The two types of formulas that we will typically write for sequences are 1, recursive, and 2, explicit. Recursive. A recursive formula uses the previous term to define the next term. Basically, what a recursive formula is saying, how do we get from one term to the next? If all you have is a recursive formula, and you want to know the 100th term, the problem is, you got to know the 99th term to get the 100th term. Okay? So if you have Google Sheets and you can just drag down, you can get to the 100th term pretty quick. And you don't have to do all the work yourself. But a recursive formula is similar to the drag down feature where it just continues to follow the same rule and it can make that sequence for you in a hurry. In a recursive formula, you must define at least one specific term to begin. Because if all I tell you is to go from one term to the next, you add 5. All right, great. You can't tell me though what that sequence is because you don't know where to start. If I say the rule is adding 5, you can't tell me what my sequence is. Now, if I say my rule is adding 5 and my first term is 8, now you can tell me it's 8, 13, 18, 23, 28, and so on. Okay? Notation can get a little tricky, so I want to try and make this clear. When you see f of 1, it means the first term. This is the notation that our platform is using. Typically, in a lot of the textbooks that I used, I would see this, A subscript 1. This is what I would always see to represent the first term. Okay, so if you ever see A sub 1, it's like F of 1. It means the first term in the sequence. That'd be the first term. A sub 2 would be the second term. A sub 3 would be the third term. And so on and so forth. This is the notation that I kind of grew up with and knew a little bit. Okay? And you still might see that. This is the same thing. All right? When you see f of 1, it's telling you what the first term is. When you see f of 2, it's telling you what the second term is. When you see f of n minus 1, that means the term that came right before the nth term. It's the term that comes right before whatever the nth term is. F of n is referring to the nth term. So I just try to put a bunch of examples here of things that you might see. But again, some textbooks might use this instead. A sub 1, A sub 2, A sub 3. And if I start doing it, I'll try to remember to put it back this way. Okay, but it's just referring to a different term in the pattern. Right here is an example of a recursive rule, a recursive formula. That's an example of what a recursive formula might look like. Here's what it is saying. F of 1 equals 8. All that's saying is, hey, the first term in the sequence is the number 8. That's all that it's telling you. The first term in the sequence is the number 8. So if I give you a rule, you should be able to write the sequence. The nth term in the sequence can be found by taking the term right before it and adding 5. The nth term in the sequence is equal to the term right before it plus 5. For n greater than or equal to 2. So what that essentially means is, let's say n is 2 for right now. F of 2, the second term, is equal to the first term plus 5. If this was f of 2, that will equal f of 1 plus 5. So in other words, the second term would equal the first term plus 5. The third term would equal the second term plus 5. F of 4, the fourth term, would equal f of 3, the third term, plus 5. And so on and so on and so on. Okay? All this rule right here is telling you is if you want to figure out the nth term, so the 100th term, if you want to know the 100th term, f of 100 would equal f of 99 plus 5. Or in other words, the 100th term equals the 99th term plus 5. Am I explaining this in a way that makes sense? Do you have questions? Sometimes this notation can be confusing for people. Questions are good. All that this is saying is if you want to find any term in the pattern, you need to take the term right before the one you're trying to find, and then, in this case, add 5. Nope, because I'm adding 5 to the previous term. Right? I'm taking the term right before it.
Yeah. Okay.
Is the minus 1 messing you up?
Wait,
No and yes.
8 minus 1 is 7.
No.
Stop.
Stop.
F of n minus 1 does not mean you subtract 1 from any term number. It's referring to what? The term before this one.
Oh, okay.
Okay? F of n minus 1 is the term that came right before this term. Okay?
It's not talking about the term itself, it's talking about the term.
So let's say, for instance, I wrote f of 20. Okay? F of 20 means the 20th term, right? F of 20 means the 20th term. So if I plug in a 20 here and I plug in the 20 here, what's 20 minus 1? 19. So the 20th term equals the 19th term plus 5. If n is 20, n could be any number, right? If n is 20, f of 20 actually means what in words? The 20th term. The 20th term equals the 19th term plus 5. Okay, there's no math to do here. Okay? If n is 30, the 30th term equals the 29th term plus 5. Okay? This does not tell you what to do with the pattern. This is just referring to the term that came right before whatever one you're trying to figure out. Okay? That's where people get goofed up, and that's why I'm asking, so I'm glad you guys are asking questions. Okay? This is what we're working with mostly today.
Is this how the all work?
Yeah.
It will always be like f of n equals f of n.
Yep. So if I write this, and I say, give me the first 5 terms in this sequence,
It'd be
what would they be?
7, 4, 1, negative 2, negative 5.
Nice job. How did you know to start with 7?
Because it's f of 1, which means it's
It told me, right? It said f of 1 is equal to 7, which is saying the first term in the sequence is equal to the number 7. The first term in the sequence is equal to the number 7. To find the nth term. So in other words, to find the second term, I take the first term and subtract 3. To find if this means second, the second term equals the first term, subtract 3. So to find the second term, I had to take the first term, which was 7, and subtract 3. To find the third term, I take the second term and subtract 3, and so on. Okay? A little better? Let me go the other way around. I'm going to give you the sequence. Why don't you try to write the rule? So we're just switching around. Instead of me giving you the rule and you writing the sequence, now I gave you the sequence. I want you to try and write the rule. Most of you are started.
Oh,
And then.
Something like that, right? I don't care where you put the times to. If you put the 2 times f of n minus 1, that's okay.
We forgot to put the n.
Yep. Or n greater than or equal to 2. Right?
Got it.
So that's really what we're working with here for the most part today is recursive. Alright? We're working with recursive. Just to quick finish the notes, we won't work a lot with this today though. The nice thing about explicit, and we'll come back to this later, explicit, you don't need to know the term right before it to figure out whatever term you're after. The nice thing with explicit is if you want to know the 100th term, you can just plug 100 in for n and see what you get for an answer. So this is where explicit is nice. That's what we've kind of been doing a little bit when I've given different problems up on the board with like tables of values and things like that. So I'm not going to go into much detail today on explicit. I'll leave this up here. We'll come back to it as we need it throughout the week. Okay? But remember, for explicit, you'll either be writing like a linear function, y equals mx plus b, or kind of an exponential function, a times b to the x. It's very similar. I'm just using a little different notation there. But again, I'm not going to spend a lot of time on that right now. I'm just going to focus on recursive. Any last questions on recursive? All right?